Now, on the last example, we focused on, notice that Mr. Adams is very careful about the wording that I use. On the last example, if you look at your notes and you wrote down everything I wrote down, you notice that I used the term relative domain. So domain means x values contained within a lower and upper boundary, but you can define what that lower and upper boundary is, and you can have several domains within an entire function. So in your textbook, it says, what is the function's domain and range? I reworded the question slightly to kind of get you to wrap your mind around what is the entire domain and what is the entire range. So we're talking about the entire graph, where before the question was regarding where is it increasing, where is it decreasing. So we focused on the domain only where it's increasing, only where it's decreasing, okay? So on this particular one, what we need to do for the domain, in this case, over the entire function, we want to know t. So we say that t is less than or equal to, less than or equal to. We need to know the absolute lowest value for v, or I mean for t. So we look at the t-axis, right? We're going to look at this axis right here. That axis right there. And it looks like the greatest value is 18 and the lowest value is 0. Oh, that's pretty easy. The range is where it gets tricky. The range is focusing on what you guys are used to calling the y-axis, but because you're fancy, and in Algebra 2, we call it v of t, right? We're going to call the range v of t now, which is like y, but it's really the value of v dependent upon the value of t. So I'm going to say v of t less than or equal to, less than or equal to. So now I need to know the lower boundary for y. So what I'm going to do is I'm going to scan to see the absolute lowest value for v of t, and that occurs right here. Then I'm going to scan the up and down and look for the absolute maximum. So that's right here. So this is v of t max, and this right here is v of t minimum. And so that's like the upper and lower boundary. So what's the y value here? 0.75, right? 0.75. What's the y value here? 3. See how we did that? Does that make sense?